Welcome to last lecture of periodic table chapter. In this lecture, we shall discuss periodic trends in chemical properties of elements. In the previous lecture, we studied about physical properties of elements. And we studied that atomic and ionic radii decrease in a period as we move from left to right. Thus, ionization enthalpy increases and electron gain enthalpy becomes more negative from left to right. This results in high chemical reactivity at the ends of periodic table and lowest at the center. So as the electron gain enthalpy and ionization enthalpy are more at the ends of periodic table, so that's why the elements at the ends of periodic table, that are group 1 elements and group 17 elements, they are very highly reactive. But the elements in the middle of the periodic table, they are having very low reactivity. So group 1 elements, which are also called alkali metals, they show the maximum reactivity at the left end of periodic table. This is because they can easily lose an electron, leading to the formation of cation. And similarly, on the right end of the periodic table, the group 17 elements, also called halogens, they show maximum reactivity because they can easily gain an electron to form an anion. Now this property can be related to the oxidation states of elements. So oxidation states of elements will determine that how quickly an element will react with some other element. So an important measure of chemical reactivity is oxidation state. Oxidation state is the measure of the degree of oxidation of an atom in a substance. So it basically tells us that how quickly a substance will form an oxide. So oxidation state is equals to the number of valence electrons in that atom, or 8 minus the number of valence electrons. So oxidation state is not constant, it can take different values. And it depends upon electronegativity of elements. So now, apart from showing trends in oxidation state, elements also show periodicity in their reactions with oxygen. So elements on the left end of periodic table form basic oxides. For example, let's take the example of one group 1 element, that is sodium. On reacting with oxygen, it forms Na2O, which is a basic oxide. Similarly, elements on the right hand will form acidic oxides. For example, let's take an example of group 17 element, that is chlorine. It reacts with oxygen to form Cl2O7 and it is a acidic oxide. Similarly, elements in the middle of periodic table, in the center of periodic table, they form either neutral or amphoteric oxides. So amphoteric oxides are those oxides that which sometimes show acidic behavior and sometimes show basic behavior. So in this way, on the extreme left they will form basic oxides, on the extreme right acidic oxides, in the center neutral or amphoteric oxides. So I hope that all the trends in physical and chemical properties of elements are clear till now. With this, we come to the end of this chapter. I hope you liked all the videos, and if you have not seen rest of the videos of this chapter, then they will be available in the description box. Thanks for watching and do subscribe to the channel.